Good morning, everyone. I'm back today. It's October 30th, 2019, and today is uh, Tuesday, I think. No, today's Wednesday. Wow. The week is getting away from me. Yesterday, I kind of got locked in a time warp. I worked about 12 hard hours yesterday, and I had other things I needed to be doing, but man, I got focused and hyper focused, if you will. That happens to me from time to time, and it was like a time warp. Like I said, I worked about 12 hours, and it seemed like maybe 2 hours had passed by the time I was through. So when I get revved up like that, my wife knows me and she lets me go and doing what I'm doing. But I've got some pretty interesting things I want to share with you today, and we're going to get back to our old friend. And the old friend I'm talking about is the LG washing machine motor, and really getting people to understand what that is. Now, I put my little test magnet right here, and of course, it has south on it. And I want you to see the right here's my demarcation line, what I call center of the motor. And each one of these magnets actually has 4 poles, okay? And so the first part of the pole is south and south, okay? And then the second one is north because it sucked that south magnet in, and then it comes up again and pushes that away. So that's south and south, and then north, and that's the way it is all the way around it. Okay, and so there's 12 of these around this, and so that makes it have 48 poles. Okay, so you have 48 magnetic poles there. Okay, so pretty neat wheel. Especially when you're discovering parametric oscillation and the way that it's actually wound. Okay, so there's 2 configurations I want you to consider, and one is Delta and the other is Wye. And when you wire in Delta, the there's no pass through. Okay, and what I mean by that is that this termination block right here is the end, if you will, of all the 3 different legs. Okay, and that's actually wired in what we call Y. Some people call it star. The So it all collects and resonates right there. Some people call that a neutral point, but that's where the reactive energy comes from. Now, something interesting about this is that there's 36 poles, and then this is double layered wound, okay? And but what's really interesting is that on leg A, it comes up on the first one and it's wound, and then it comes down to the second one on the third one, and it's in series, and it's in series all the way around to the termination block. Okay, and so when you're looking at series, you have to understand that the induction from the first pole all the way back in series is you have 12 nodes on that leg in different positions all the way around it. Okay, and so when you put it in series, you're reducing the amperage but increasing the voltage. okay, through the resistance of the copper wire. Okay, now what would happen if you wound all that in parallel? Okay, in other words, it would change the effect and make this more susceptible to handling current, okay, over voltage. All right. Now, the voltage and current work hand in hand to make magnetic effect. So when you're generating, you want to create current, okay? And as you generate current, it makes it easier to spin, and the current bypasses your Lenz's law, okay? So the way things are wired is what causes the resistance. And so understanding the difference in pass-through amperage and pass-through voltage, and so if you have this wiring as a generator, this is going to be a very resistive generator for voltage. Now, if you wire it for current in parallel, it's not as resistive. Okay, so the understanding the difference is where I wanted to get you to understand. Our old friend taught me a lot. Thank you, Gerard Morin, for getting me into that type of frequency motor. I call them Oriental motors, and been playing with it for a very long time, and got some pretty cool controller for it, and the very well worth doing that. But like with anything, get you your wiring scheme of what you're wanting to do, but understand that the way it's wound from the factory is wound as a series motor, and it does offer parametric oscillation in the series leg. And as each node in resistance in that area becomes a node, you can actually tap energy off of that just like you would a battery, if you will. Okay. Now, something kind of curious that most people don't realize, and John Bedini, thank you, John Bedini. When I started messing with the John Bedini wheel, why did you face all the magnets one way and just have a single coil up there? And then also I demonstrated it with an air core, and then started playing with the different frequencies. And you can go back through my videos and see that part of it. So now the trick yesterday was, dealing with the AC Delco alternator, automotive alternator, and those are readily available and very inexpensive. And I wanted people to be able to experiment with this energy and come up with their own findings, come up with their own switches and telemetries. But just like the LG washing machine motor is a series motor, so also is the basket weaved alternator motor. It's already in series with 6 phases on it. And so for parametric oscillation, you do need it to be in series. And but the other thing is understand that the motors and generators back in the day at Tesla, they didn't have alternating magnets. They faced the magnets for what they were wanting to do. And like I stated so many times, to me, north is pressure. Okay, that pushes out. If you want to push energy and radiate it, use the north face of the magnet. Okay, if you're wanting to suck energy from another source, then you'd face all the south magnets out and have those facing south. Now, one of the projects that I was commissioned to work with was a string motor, and the string motor, as shown, with the north-south alternating poles and everything. I think those were rewritten. I believe the guys that actually did that, they had one string motor with all north-facing magnets. They had one string motor with all south-facing magnets. And as we know, when you get things going in one direction, then you can combine those two into the AC motor. And when you go into parametric oscillation in the series circuit, you actually get a beneficial boost with the system. So I hope that's a good heads up for people that are interested in working with good string motors. I've got to go back and prove that. But from my research and what I'm finding, I believe definitely that the day motors, what they call dynamos, those were actually biased facing magnetic generators, either to push and radiate or to suck pressure. And I think that's a very easy way to explain it and what happens in the magnetic field. I haven't purchased my wheel. I'm going to modify. I want to explain more about this one. This is all laid out 120 degrees apart. Okay. And all I'm going to do is I'm going to go 140 degrees this way, and in place of magnet, it'll be past where this magnet is there by 20 degrees. And then I'm going to go 140 degrees this way, which will be past. And so it's going to leave an 80-degree difference between those two. And I believe with all the north-facing magnets that with the stator, because of the heuristic in the metal, that it will automatically make alternating current, even though all the magnets are facing north, and be much easier to run. Then all I have to do after I do that is dynamically balance the wheel, because I'm sure it's going to be out of balance after I do the configuration on that. So, but the thing that I found very interesting is the basket weave, and they're around 40 degrees phasing, like this stated. There's 12 lines coming off of it and 6 circuits. And one of the circuits actually goes backwards. Wow, that was a good clap of lightning. Wasn't too far away. So anyway, just wanted to point that out to you. Again, I lay all my stuff out with the protractor. And what I found interesting when I laid this out is the golden ratio and the Fibonacci spiral that comes into the equation when you lay that out. So I'm going to hit the neutral point within that, and it ties right into the Fibonacci cycle. So anyway, I hope you enjoyed this video. I hope you're having fun. Wow, good lighting around here. Keep studying, keep working, keep making your products going. And we'll see you next trip.